So today I'm going to solve difficulty level 1500 problems. So continuing in the row, I'm solving these three problems, 1, 2 and 3. So this is the first problem. So, you are given okay, here we go. So we are given a Rubik tree consist of n vertices. Vertices are number from 1 to n. An index can be a root of the tree. A tree is connected undirected graph without cycle. A Rubik tree is a tree with a selected vertex which is called the root. The tree is specified by an array of ancestors b containing n number. B is the ancestor of I. Yeah. So this is the example. So 3 1 3, and the ancestor have a value bi. If I is equal to I, then this is a root. Okay. You are given an array permutation of vertices of a tree. If it is possible, you can assign any positive integer weight on the edges so that the vertices sorted by distance from root would be sorted by distance would be from the given permutation p. Okay. So first of all, let me open a whiteboard. So what is given actually? We are given kind of a tree actually. So let's say this is the given tree, and we are also given a permutation of all the vertices. So vertices like something number like 1 2 and 1 2 3 4 5 6 7 8 9. So permutation like be any permutation of 9 number, like 7 8 3 4 1 8 1 2 3 5, something like that. Okay. So permutation is given. So what is given that? So we need to find uh, the distance on the edges, and it should be a positive integer. So we have to give every edge is some number over the value of the edges. So distance will be, so distance from and distance of u. So I'm just creating another vector, that is distance vector, and the distance of any u will be equal to distance from the root. So I have to prove that if I'm sorting all the array, all the nodes according to this vector, according to the distance from the root, so it will be from the same array. So like if 7 is before 8, so distance from root to 7 is less than 8, less than 3, something like that. Okay. Okay. So what can I say that? So first of all, I can say that if the distance of like like I'm 100% sure that if I'm going with some careful consideration and some observation, some details of this problem. So first of all, I can say that uh, the roots, or can I say children must have distance greater than parent. That is 100% sure. So like in the case of 7 and 8, so 8 must have higher distance than 7 from the root, because in distance root to 8 will be an addition from root distance from root to 7 and this, and I am already told that in the problem it is already stated that this should be a positive integer. So I'm 100% sure that the distance of the child will be greater than their parents. If it is not, then I can say that I can not able to do that. Okay. So what this conclude is in the permutation I have to say that, so their uh, child of a child of a parent should be or must be come after the parent. So its child, like, if it is this in the permutation, so 7 must be before the 8. Oh, and 5 must be greater than all these their childs, or child of child, or you can say a subtree. Okay, this is a simple consideration. Observe. So next thing what I need to do, okay, so let's say if all these conditions satisfied, now I have to what happened. Okay. Let's say all these conditions are satisfied. Now I have to find the, like, how to assign the values. If this is question about yes or no, so then about these things are good to go. But we also need to find the distance which I have to provide. So so you, so maximum value I can provide for any edge, the weight of an edge would be 10 to the power 9. So weight of all the edges should be less than 10 to the power 9, or less than or equal to. So you can think that how should I provide. So first thing everyone's mind pops up is that one, like this is a tree. Okay, and I already know that this can be a valid tree, so that, like, children are always less than, like, always far, or I say the distance of the children is greater than their parents, then it is a kind of a valid tree. Yeah, it is okay. Now I'm saying that, okay, I'm just giving the details, giving the edges sum. Let's say I'm given this is 1, then this is 2, then I'm just try to provide the sum. So I'm just, let's say, up to here I just total provide the sum that is 3, then I'm providing the sum that is greater than up to yet. Okay, let's say now here I have to provide 8, then how much I provided, 4, 2 plus 1, that is 7. Now I have to provide greater than 7. So according to this, I'm always 100% sure that distance is always greater than, let's say, is a kind of this thing. This is 2, this is 7, or and this is 3, 4, 5, 6. So let's say the uh, array permutation is something like that: 2, 3, 4, 5, 6, 7, and 7 is coming at the last. Okay, so this distance should be greater than all of these. So let's say I'm just giving 1, 2, then 4, then 8, then here should become, and according to my this definition, this to 16, and it is always greater than the all this thing, all the given thing. Okay, but here is the problem. So there are total number of what is 10 to the power 5. Then I have to do 2 into 10 to the power 5. That is too much large number, and this will gonna exceed my limit. So I cannot provide this number. So basically, this is the first thought of mine. Okay. So what I can say that what is the solution? Like, I'm telling you how to approach a problem. What is the, if you getting into the uh, get into something wrong, so how to improve and all these stuffs. Okay. So if you carefully observe that, it is given that the permutation is something given. So if I draw any type of, let's say, the same example, like 1 is this is 7, this is 2, this is 3, my this is 4, this is 5, and this is 6. Okay, so this is the simple example I have, and permutation is something like uh, 1, 2, 3, 4, 6, 5, and 7, and this should be the greatest. So I'm saying that, okay, so let's say here index will be the index. These are the index, and this is the permutation given. This is the permutation, and these are the indices. let's say 4, 5, 6, 7. So I'm saying that I'm just giving the all the child their value as they are in the permutation. Like what I'm to saying that the sum from child to or any node to root will be equal to at the indices equal to the indices at which it appear in the permutation. Let's say 6 appear on indices 5, so its distance from root to 6 is 5. That I want to say that. So I'm just starting from here. So first of all, what is the index of 2? I'm gonna, by using any map or any something, I'm gonna find out what is the distance from 2. Let's say 2 is 1. So first of all, let this is 2, this is always 0, and the indexes will be 2 minus the parent. Okay, so I'm saying this is at the distance 2 from the root, like this is at the 2 indices. Okay, now the third at the distance 3. So I come here, the distance is, I want distance from root to this is equal to 3. Okay, now I already told that uh, how much sum I already aggregated. Okay, how much sum I already have while visiting from the root to this point. So will be equal to, I'm 100% sure that will be equal to the indices of the parent of this child, of this node. So indices number is 2, so I'm 100% sure that sum up to this node is 2, or I can use a variable something like that, but this will be a good idea. Okay, so its sum will be 2. So how much I need to assign more? I need to assign more. So this node will be have sum 1. So total sum will be 3. Similarly, I'm just coming up to here. The 4 is 4 number, so I have to assign it one more again. And this is at 5. So 4 is already up to here. I need to assign 1. Now this is at 6. 4 is up to here. Sum is 4 up to here, so I assign 2. And this up to here is 0, so I have to assign 7 here. The sum of these edges is 7. So you can say that by using this technique, I'm 100% sure that every this follows the permutation. The sum from root to any node is follows the sorting of the permutation. The in the way that the permutation is sorted, the node is the same way the distance is sorted, because I am assigning the indices of the sorted of the given permutation. The value of sum from root to any node is same equal to is same to that is in the indices of the permutation. Okay, that I need to do. So jump into code. Let's um, okay, what is that? What we are given is that we have test cases and the number of and so I need a graph. Let me create a graph g. Let me resize it to n plus 1. Then for n I is equal to I, let's say I is equal to 1, I should less than n and I plus plus, and making it gi dot clear. Okay, then I'm giving a, first of all is bi, that is the, it is going to that bi encode some rooted tree. Okay, so I need to find root, and root will be, so for I and I is equal to 1, I less than equal to n, I plus plus, I need to be c in b, and if b is equal to I, so root will be is equal to, then this I is a root. Okay, and I need to continue it, else this will be a edge, that is I to push back p and g of b dot pushback I. For pushback, I already define a shortcut. PP is a kind of pushback. Okay. Now I need to do a BFS from the root, and that's it. So void BFS int p or int p for, so that it doesn't repeat on same node. Okay. If it is equal to parent, if one of the child is equal to parent or one of the connected node is equal to parent, I need to continue, else DFS of it is v. Okay, this is a simple DFS. And now let's see what is the modification we need to do. First of all, I need to find the distance. So I need to find the what is the indices of the current node in the permutation. So first of all, I need to take a permutation. So vector of need int I p of size n plus 1, let's say n plus 1, and int I from 1 to I less than equal to n, and p of I will say, let's say this the current SC and permutation x I is equal to x. That is my given permutation. Now I need to find the index, so I will gonna use a map of int comma int m. So here m dot clear. So what I need, m of x I need to give, okay, index I. Okay, that's it. Okay, this is the parent. So first of all, I need to find this, the current value. What is the index value of this current node? Index of parent is equal to, what is that? That is mx of v. From I got the index. Now I need to find the index of child. That will be is equal to m of it. So for checking that it must be true, so index of parent, or I will say index of child, must be greater than index of parent. Okay, because this is always must be there, because the sum from root to let's say this is the parent and this is the child, so the index of the parent must be smaller than, okay, because the sum of child is always greater than. So 3 must be, let's say this is the 3 and this is 4, so 3 must be present before the 4, that I want to say. And that was it indicates, let's say if it is node of parent is greater, so I will say return, and what will I gonna do is I say val is false, so I need to create a val bool val is true, and I need to val is true. And if I say that if val is false, come out false, I'm 100% say that it is not possible. I'm gonna return it. Okay, now I need to assign the values. Okay, values to the this to the indices. Okay, so I need to vector of int result. So result size will be equal to n plus 1, and first of all I need to clear that all value must be equal to 0. So I is equal to 0. So I need, so let's say the value will be the current value of this I, or I will say how much sum I require from the root is, that is equal to int child, and that is already come, that is int of parent. Okay, so I'm saying that if it is 2, that means I need sum from root to this point is 2. That is the index of the child. Okay, in which this appears on the permutation array. Okay, and I'm say that the sum up to this point from the root to its parent will be equal to the indices of the parent. So how much I need to assign to this edge, that is the difference between their sums. So will be the result of index of this. So I need to create a map again. So map will gonna give me the, if I put the parent and child, it will gonna give me the index. So the index of the edge. So I need to create another map. Map will be take that is a node, sorry, the edge, and it will gonna return me index. So I will gonna say it index, and I will gonna say that index of I comma b is equal to index I, and index of b comma I. So maybe I don't know which one is parent or which one is child. Okay, so I will take the both the possibilities, I or b or I. So I need to pass this. I'm gonna pass it, that will be good. Hmm. So map of pair of int comma int and m indices. So this index will be index of the it comma v or v comma it, everything is possible. So that will be the current sum and index. Yeah, I got it. So what do I need to do? So for int I is equal to 1 to n, I need to output the value assigned to each of the edges, that is the rest of I. Yeah, here we go. 11042 11042 minus 10. Let me check with the okay, yeah, okay. So this is the second problem. What is being given is that Kashmir is has a rectangle piece of paper with the check field of size and into initially all the cells of the field are void, and let us denote the cell with the coordinate I vertically and j horizontally by I comma j. The upper left cell will be referred to as 1 comma 1 and the lower will be n comma s. To the draw ticket ticks of different sizes on the task. A ticket of size d with its integer in the cell I comma j as follows. The first center cell I comma j is painted black, then exactly D cell on the top left diagonal to the center and exactly D cell of the top right diagonal to the center are painted black. This all cell will be coordinated I minus h, I plus h. Okay, I minus h and y will be j plus h and j minus h. Okay, for all h0 to d are painted. So in a particular tick will be this one, and already painted cell will remain black if it is painting again. Okay, this is the size. You are given a description of a chair, claims that that will come from he do some ticks on it. So ticks can be of different sizes. By the size of a tick is at least k. Determine whether this field can indeed be obtained by drawing some of these. Okay, so k is very small, k and m size is very small. So we can do a build for something like that. Yeah. So you can say that k size is 10 and m size is 19. So what is given is that, so I'm gonna go for a brute force, okay, because size is so small, and I let's see calculate the time complexity of a brute force, and we will gonna see that. So it is a kind of rectangle is given, Okay, so what is given is that, so I can paint it as some color. Okay, and I will gonna paint this as, this cell will be, um, what is given is that this cell is I minus h, I minus h or j minus h, and this one will be I minus h and j plus h. So I am gonna play these cells, okay, from these and this in the same direction, in the sign of a V, um, V letter. So we need to find that if it is given is possible or not. So I'm gonna say that if I got a asterisk sign, so it will be the blue color, black color is represented by them by an asterisk sign. Okay, this sign, the symbol, I find the symbol, so I'm gonna visit all these cells. So let's say I'm gonna go into this cell. So if it is having the asterisk and this is also having the same symbol, so I will go next here and here. Okay, now I'll find that if both the cell having the asterisk, then yes, then I'm going the upward. So I'm just moving upward until I will get up, I will hit the, yes, you can say the outer line of the cell of the rectangle, or I will end up with that one of the cell or both of the cell don't have the same symbol. So I will gonna calculate the distance, how much or how many turn I take. Let's say 1 2 3, that much I will count. Let's say it will be naming as my D, and I will gonna check with K. If this D is smaller than K, then I will 100% sure that I can't able to make this, because the height will be at least K, at least D. Sorry, at least K, yeah, at least K. Okay, so if it is greater than the size that is come from this position is greater than K, I will gonna say that like these cells can be is possible. Okay. So what is the time complexity? If I'm going for every cell, so a number of cell will be n into m, and let's say it will gonna cost me upmost n for each of the cell. Okay, because I can go up to from the in this row, then this row and this row. In that window I can go, if because when I reach to this row, then I will gonna hit the outer cell, or I will jump outside the rectangle. So these are the number of cases, so maximum that much of is required. So the time complexity will be 10 19 into 10. Okay, so will be 10 to the power 3 around for each test cases, and number of test cases is 100, so into 10 to the power 2. So we can easily do that. Okay, so brute force will easily gonna work here. So let's see the code. If you already understand this, so if you are confident, so you can do by yourself. You can pause the video and do by yourself. Okay, let's do that. So I am the test cases, then and the test cases, and then nmk. Okay, and nmk. This is n, then m and k. Okay, now I given a vector of size n to m of a kind of characters. Let's say matrices of size n, vector of size n. Okay, so I need to output from y to n and from j to n, seen mat of I comma j. So let me apply the brute force, and we already see that brute force time complexity we can easily pass out of it. So whenever I found any that is painted, any cell that is already painted, int k, let's say h, and h should be less than equal to I, because it can maximum go up to I, because we found any here from any row the current I is, let's say, 0 1 2 and this is 3. Okay, so I can up to go max to up to 3, because after that I will be outside the rectangle. So it will be A and H plus plus. Let me take a count how many cell I will be there. So the cell will be int x comma y will be I minus, it is already given, I minus h, that is I minus h, and y will be two possibilities, I minus h and let's say y1 is equal to I plus h. Okay, so first of all let me see it is outside or inside. So let me see if it is possible or not, x comma y pair and possible of x comma y1 pair. If they are possible, then I will check if mat of x comma y is must be equal to this sign, this character, and another one is x comma y1, this is equal to this sign. If it is okay, I will say I will go 9.
What would you like to search for?
Okay, else I will gonna break out from this loop. So if count is let's less than equal to k, I will gonna break it out. Else I'm 100% sure I will gonna make it okay. Let me create another array, another matrix. So I will take in as a boolean and name it as a check, and I will say it will be possible or not. I will give it as a true or false. Okay, from 0 up to count it can be possible. Okay, because up to count we can go. So I will say that mm, check of x comma y is equal to true, this cell is possible and this cell is also possible. So first of all I need to define a bool possible. So for, let me say, it is possible for int x comma y or not. So if x is greater than n, or if it is outside, let's say n or x is less than 0 or y is less than 0, I will say it is not possible. Else it is possible. So I need to define x n comma I'm outside. Okay, I made them global variable. That's good. Why it is showing uh, double x is there? I think so it is good. So I will gonna check it out. So if any cell is painted black and I didn't like, it can't be possible. So I will say this cannot be done. Let's say if any cell that is I comma j and it is painted black, but it is not able to, so it is check is false. So I'm saying that it is not able to. So I will gonna return no, but I have need to return no. And then else everything going to perfect, then answer will be yes. No, no, yes, 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 no, no, no. It is not giving good answer, yeah. So why it is not giving me the answer? Okay. So let me check. So it is 231, then this second one is also giving no. So this is 2. I'm taking mij. And if it is this one, I'm gonna get a count, and it is should be less than equal to I. Then h plus plus, if I will be I minus h. Oh, see, sorry, this is j minus h. These are the y. Then still I need to change here. This is j out. This is still it's interesting, man. So I will just checking xy pair and xy1 pair is possible or not. It is possible, and xy is this one. So with this one, I will gonna increase the count as I will gonna break. If it is less than, so how much k is there? So from here, k will be count will be 1, here will be 2, here will be 3. Okay, and what will be 1 and 2? Okay, that will be good. Here this will also good. If it is less, then I will gonna break it. Otherwise, oh, I got it. If I'm gonna break it, then it will break from this loop. So I don't. I need to. I will say I need to continue this. Still, I'm gonna say it is true. It is true. Okay. 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 From 0 to I, j to m, j plus plus, I plus plus. If I comma j is equal to this one and it is 4, I will say no, and it will gonna return. Oh man, this is not returning. Yeah. Hmm. Okay, so test cases. Then I have taken an MK. Let's check. I think so. It is should be giving me the correct answer. Why it is not giving me? So as a mad I comma j is this one. Then in I minus h j minus h plus plus. Okay, this is perfectly fine, 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 fine. Everything is fine. So it is not giving the correct answer in let last. So what will be the last? This is the last. It is giving me no. Yeah, it is no. What is happening going on? Then why it is giving me yes here? Run. If I'm gonna run it individually, it will gonna give me yes. Otherwise, it is what the fuck is happening? Mm, I don't know what is happening. If I'm running this individual, then it is giving me correct answer. So there may be issue of like something is already will be there. I comma j. Oh, oh. Yeah, yeah. Here we go. So there is a printing problem, you can say. I just printed NN. Hmm. Why it is so? This is ridiculous. For me, it is giving me correct answer, but as here it is showing a. So let me run into his environment. Runtime access. Why it is giving me runtime access or something? For the second one, it is giving me runtime access 49 or something. So I'm just n comma m n comma m j comma m must be, I'm just defining m or n, there will be a confusion for me maybe. So x comma y 1. So x is greater than equal to n, y is greater than equal to m, x is less than, y is less than, is true for returning false. So n comma m. X comma y, and I'm taking this. These are all good. I j j 100% correct. X y x y 1 x y x y 1. First of all, let me check where is gaming math. Still giving me runtime. So what I need to do? Let's say I need to, yeah, now it is running fine. I may check that this bool, this for loop is running fine or not. Yeah, this is also running fine. So let me check this first, if loop is running fine or not. Yeah, this is causing error. Oh, so I need to put an, yeah, this is also still running fine. Okay, so in this for loop there is a problem. Okay, so h will be less than equal to count. I'm increasing count, that is 100% correct. Okay, but check is x comma y and comma m 100% good, and everything is similar to this, no? X M Y, it is 100% similar to this. Okay, sorry, it should be less than, because if it is running by 4 time and it will gonna run from 0 to count will be by 4 time. Okay. Ah man. Okay, so this is the third problem or the last problem of the day. So Mr. Chanak has a new game called dropping balls. Initially Mr. Chanak has a grid of size n to m. So each cell x comma y contain an integer a x comma y, noting the direction of how the ball will move. So if x comma y will gonna be, the ball will move to the right x y plus 1. If it is 2, then it will move into the bottom cell. If it is 3, then it will move into the left. Okay, every time a ball leave x comma y, the integer will become 2, so it will gonna move into this same, in the same column. Okay, Mr. Chanak will drop k balls sequentially, each starting from the first row and on the c1 to ck column. Determine in which column. So I need to find out the column it will gonna end up. Okay, so first of all I given n comma 1 a grid and a value of k. Okay, so if we are, so first of all let me carefully observe the, and let it be. Okay, first of all we are just given a grid. A grid is given of size n comma. Okay, so I'm 100% sure that it is already given is that after visiting a cell it will be turns out, uh, it will be turned out into 2. Okay, so each cell will be, so I will gonna calculate the time complexity. If I'm just running a, what I'm running, I'm just going to with a simple or a kind of a brute force, like what is given in the question. I'm just going with that. But I'm going with that, uh, let's say it is given is that some ball is dropped. First of all, like, let's say in this column, in this cell, one ball is dropped. So I'm gonna with the kind of bfs. So it will be gonna do it, move here, then move here, then move here. So I'm gonna apply all this the same thing using the BFX. Okay, what is given in the question, I'm applying the same thing. I'm not doing any optimization. So I want to calculate if it is possible or not. What is the time complexity of this? So time complexity will be, so I'm first of all I'm 100% sure that each cell, after visiting each cell, it will be converted to 2. Okay, so so that much of the cell, so these will be visiting only once. After that there are k, there are k balls. So if all will be 2, I'm 100% sure that after n into m times, this all become 2, 2, 2, 2, because that much number of cell is there, that is n comma m. So it will gonna visit but every ball will gonna visit in the same direction. That will be n, the size of this cell. So the total time velocity is this one, n into m plus k into m, and the size will be 10 to the power 3 into 10 to the power 3 plus 10 to the power 5 into 10 to the power 3. So it will be 10 to the power 6 or 10 to the power 8. That's it. No? So in, and how many seconds are given? 2 seconds are given. So it can be possible. Like in, depending upon the operation, if it is some plus minus or so, C++ code run approximately 10 to the power 7 to 10 to the power 8 number of time it will gonna do operation in a once in 1 second, or in a 2 second it will be okay. In kind of, it will be gonna set 2 times. Okay, it will not gonna increase that much, but it will be gonna in 2 seconds it will 10 to the power 7 into 2. Okay, in each second it will uh, run approximately 10 to the power 7 to 10 to the power 8 depending upon the operation we are applying. So it will be kind of a um, hard time of kind of operation. It will gonna take time. Otherwise it will be simple operation like plus minus. It will gonna uh, easily we can go up to 10 to the power 8. So I think it will gonna pass out in 10 to the power 8. Okay, okay, so that's it. We need to do a simple BFA. So first of all, for each cell we am going to, what I'm going to do is, let's say one ball is there. So I'm just in a going to take a q, a simple BFX, the integer, like this is the x comma y, and I will see if it is 1, 2 and 3. I will gonna apply the same process. If it is 1, I'm gonna move it to here. From here I will see if it is x comma y, this is how many, then I will gonna here, then here, then here, kind of the operation it is given. Okay, or I will not gonna apply BF. I'm not using any q, because I'm already knew that always there will be only one ball x comma y. Okay, and there always be one cell that is that much, this much. Okay, so I'm gonna apply just using taking holding x comma y as an integer. So if you don't know understand this very well, so let me code, then you will go and understand it. And somebody, if somebody understand that one, so do by yourself. Okay, so we are in n comma m. And okay, so first of all I need to take a vector of a of size n comma vector of int size n. So for I to n, and for j to n, just seen a of I comma j. So what after that I'm given is that k indices. So I need to k k okay, let's say h from 0 to k and h plus plus. So we are just given a y in a which column it is, and x will be 1. It is already given that. We are just placing the ball in the first row. Okay. So why it is true, I'm gonna, so it is kind of a mm, BFS, but I'm not using Q, but because I'm already know that it will always having a one value, because it is already given that we are just placing it sequentially. So what is mean push of the ball leaving the uh, that will be so it will be end up, so it will here. So K ball has been dropped sequentially. That means if first will drop, then a- after the first one it will reach to its end point, or move outside the column, then the second ball will be dropped. Okay, so it is all the operations will be going to do sequentially. That's why I'm 100% sure that this will be only one in the queue, in that x comma y will be there in the queue, so I don't need to have a require of a queue. If you want, you can use a queue as well. So if I'll say what is the okay, so if the value of that is x comma y is equal to 1, x comma y is equal to 1, else if x comma y is equal to 2 and it is 3. If it is 1, then the value will be, I will say if it is 1, it will gonna increase y, so y plus plus. If it is this, then this will be x plus plus, and here it will gonna y minus minus. So I'm just applying the operation, and the xy will change. So if it is outside the x comma y, mm, let's say if y is greater than equal to n, because y is always increasing, so I'm 100% sure that uh, this operation is applied, or this operation, but I'm 200% sure that x will gonna make it out. X will gonna make the ball outside the grid, because after that, uh, after applying this operation, the a of x comma y will become 2. Okay, because it is already given. After a ball leaves the cell, so its value will change to 2. So if this will gonna change, if x is, it will outside the this one, so I need to find where, so I will get a vector of diamond result of size k. Hmm. So it will be of I is equal to, this column is y column, the result of h, sorry, and I will gonna break it, because if it is crosses the, because after certain point it will be become like, here will be everything will become 2 to 2 2 2 in the 2 operation, the ball will go down down down, and if it is to go down outside the, crosses the n, crosses the limit of the grid, so I will say it's just pop out from the grid. So I'm gonna break, and this is the y, this is the column it will gonna end. So what is the result for all I to k? That is equal to result of I, see out that. So let me test on the examples. Oh man, what is given is that 2, wow, 1 to 1. Oh, it is not correct. 1 to 1 is not correct. X comma y, if it is x, sorry, greater than, if it is greater than y, oh, I got the problem. So first of all, I need to make them x plus 1 and y plus 1, and then it will gonna work fine. same same issue. So yeah, for 1 to 1 will listen from 1 to n, 1 to n and j. I will making it at n. Okay, now the result of k for 0, it having the y is 1, x is equal to 1, that is this 1 1. In one operation it will gonna y plus plus, it come out here. When it comes out here, else if else. Oh, that's the problem. Oh ho ho ho. So what I need to do is, after this operation I will say pre x comma y. I need to store the pre x is equal to x and pre y is equal to y. Because what I need to do is, a of pre x I will gonna change pre x and previous y is equal to 2. Yeah. Okay, it is done. Okay, thank you.